Hello everyone. Today we're going to talk about Physics 253, Week 3, problem number 23.19. In this problem, we are asked to calculate the electric field strength between two charged spheres. As you can see in the diagram I've drawn out here, I'm using the data that were given in the problem to set up this problem. So what we're going to do is as you can see, we have our 2 centimeter in diameter. So that's important because that means that across here, and they're going to have a radius of 1 centimeter. And they also have a space of 5.2 centimeters between them. So we have our different charges of the spheres here, one with a positive charge and one with a negative charge. These arrows would be going all the way around, but for the sake of the drawing and simplicity, I did not do that. But what we can do is we need to find the midpoint, right? So if we're using the midpoint, we need to solve for the distance between them. So we're going to do this right here. And what we're going to do is we're essentially going to try to solve for this radius, or r, so we can use this equation for the electric strength of the sphere. This equation is given in chapter 23.4 of the e-text, and it is essentially a variation in which we have our charge Q, our charge strength in coulombs Q, and it's essentially just being multiplied by the Coulomb constant, or the electric constant, and that's going to be this value here. So what we need to do is we need to find the electric field strength of each sphere and then add them together. So what we're going to do is we're going to find that midpoint, as I was talking about, by doing 5.2 centimeters, and then we're going to add 1 because this distance here is going to be 1 centimeter, and then this distance here is going to be 1 centimeter because we're trying to find the center here. So after doing that calculation, we get 3.6 centimeters, and then we're going to convert that for meters for the sake of the equation. And then we're going to add the two spheres together by using this equation here. This is going to be our charge strength Q multiplied by our constant K and divided by our radius squared. And we're going to do that for both of these here to get that our electric field strength in total is 1.24 times 10 to the 6 newtons per coulomb. This is a cool concept that we will hopefully be expanding on in our section about Gauss's law, because some of the stuff that Gauss does with electric fields relates to this topic of having charged spheres interact with each other. So I hope you guys found this video helpful, and thank you very much for watching.